All right, college algebra class, we're going to look at 3.3 notes, so we're going to solve some more quadratic equations. These ones are going to have complex number solutions, so as they're not going to be factorable, and we'll probably use mostly the quadratic formula to solve these ones, but what we'll see is that the discriminant's going to be negative. But then we'll work on, how we deal with the negative solution, the negative discriminant, and finding the complex solutions. Okay, so we're going to perform arithmetic operations on complex numbers and then solve quadratic equations that have complex solutions. So we know that the definition of the imaginary unit I comes from the square root of -1. That's what I is defined as. We know that it's not a real number, but that's where we come up with the imaginary number system, the complex number system. So it would follow that if I is equal to the square root of -1, if I were to square both sides of this equation, I squared, if I square that, that yields this equation. I squared then would equal -1 because the square root here would cancel. Okay, so that's important as well. So anytime that we're simplifying these expressions and we have I squared, we want to change that into a -1. We never want to leave I squared in an expression. We want to replace that with -1. Defining the number I allows us to say that there are solutions to these certain equations where before we'd say just no real solution, which is true, but now we can solve them and give imaginary solution answers. Okay, so a complex number is a number that can be written in the standard form a plus bi, where a and b are real numbers. The real part is the part that has the a, and then the imaginary part is the b part with the I after it. So every real number can also be written as a complex number. It's just that it would have 0 for the imaginary part. Okay, so complex number a plus bi where b is not equal to 0 is called an imaginary number. Complex number a plus bi with a equal to 0, b not equal to 0, sometimes called a pure imaginary number. So like examples where you just have like 3i, -i, 5i, 7i, where you don't have the part being added, the real part being added with it, those are pure imaginary. Okay. Otherwise, they'd be complex where you have the combination of the two. Okay, so when we simplify, certain square roots of negative numbers, we know that we pull that negative out and it becomes an I. So for example, if I had the square root of -7, I would pull out that negative as I, so I just write it as I times root 7 like that. Okay, so simplifying these problems, we know that when we're multiplying radical expressions, we just multiply the radicands. However, before we do that, we know that each of these is representing an imaginary number, so it's important to simplify them before you multiply the radicands. So what I mean is we want to pull the I out, so I'd have I times root 3 multiplied by I times root 3. And so I want to multiply the I times I first, and then the 3 times 3, so I'd have I squared times root 9. All right, now what we said before, I squared is -1, and then we know that the square root of 9 is 3, and so our answer is going to be -3. All right, if you multiply first, and then it's like the negatives cancel, and you would get, just square root of 9, which is +3. That's not the correct answer. Okay, the correct answer is -3. So make sure you pull those i's out before you multiply. So this one, I root 2 times I root 8, I squared root 16, so that's -1 times 4, so -4 is the answer. Okay. All right, so we have a few different operations. We have adding, subtracting. This is squaring, but it's like multiplying and then dividing, so we'll do one of each. So for part A, adding is real simple. You just basically combine like terms. Combine the real parts, combine the imaginary parts by addition. So -3 plus 5 is 2. 4 plus -1i is going to be plus 3i. That's my answer for A. For B, just remember if you're subtracting, and we have two parts in parentheses, you have to make sure you kind of distribute that minus. So a lot of times we think add the opposites. We change that and change that sign there. And so my real part is going to be -6. And then when I combine the -7i, and then it's going to become +5i. So that would, when I combine -7i, +5i, I get -2i for that solution. Okay, so for C, -3 plus 2i, and that's quantity squared. I'm just going to write it out as a multiplication since I'm squaring it. just to kind of talk through the steps of squaring a binomial. So we basically have to FOIL this out again. So we're going to take -3 times -3, and so we get +9 there. And then the outer and inner products, right? So -3 times 2i, -3 times 2i. Each of those is -6i, so I'll have, -12i. And then when I do last times last, 2i times 2i is +4i squared. And so when we simplify this, anytime you have I squared, that changes to -1, so it changes this to a -4. So I've got 9 minus 12i minus 4, and then I can combine the 9 and the -4, so I get 5 minus 12i. So that should be my solution there. So again, don't ever leave I squared in your answer. Always cancel that and then just change the sign because you're multiplying by -1. All right. And the last one. So on part D, it kind of looks like it's already somewhat simplified, but the thing is you can't, in a similar way to where we wouldn't leave square roots in a denominator, we don't really want to leave an I in the denominator either, so what we do is we multiply by the conjugate. So we multiply by 4 minus I, the numerator and in the denominator. You have to do to both because we have to, keep it an equivalent fraction, so we do multiply the same thing on the top and on the bottom. And so on top, the 17 times 4, that's going to give me 68, and then 17 times minus I is minus 17i. And on the bottom, we're going to basically FOIL this out, but because they're conjugates, the outer and inner products cancel. You get -4i, +4i. So you just go 4 times 4, 16, and then I times -I is minus I squared. And remember, minus I squared is going to be the same thing as +1, because I squared is -1, so it's like 16 minus -1. So on the bottom, 16 minus -1 is 17, and then we've got 68 minus 17i on top. And as I'm looking at this, it doesn't always work out this way, but we saw here that 17 times 4 was 68, and then so these are both factors of, or multiples of 17. We can reduce. 17 is a factor of both. So if I take 68 divided by 17, that's 4, and 17 divided by 17 is 1. So 4 minus I would be the simplified version of that. Okay, so all I did was divided each of those numerators by 17 since they divided evenly. All right, so quadratic equations with complex solutions. It says we can use the quadratic formula to solve quadratic equations if the discriminant's negative. There are no real solutions, and the graph does not intersect the x-axis. That's when they say verify graphically, that's basically what you would do is, you can graph it on your calculator and see, well, if I got an imaginary solution, then it shouldn't cross the x-axis. Solutions can be expressed as imaginary numbers. So let's take a look. So first one, you can complete the square too, but I think most of us would choose the quadratic formula, so that's what we'll go with here. So x equals -b, so that's -3, plus or minus the square root of b squared, which is going to be 9, minus 4 times a times c, all over 2a, should just be 2. And so I got -3 plus or minus, and this is going to be 9 minus 20, all over 2, and so I've got -3 plus or minus the square root of -11 over 2. Finally, -3 plus or minus I root 11 over 2. And that's all the further we really need to go with that. And it said support your answer graphically, so if you want to, you can type it in. I think I put it in here, yes. So I've got x squared plus 3x plus 5. And basically all you're really doing to verify this graphically is to show, and it's not going to give you necessarily this exact solution, but it's just what you're verifying is that it doesn't have real solutions. So when you look at the graph, you see this parabola that does not cross the x-axis. Verifying it has just imaginary solutions. Excuse me. Okay, so next one up, we've got, now remember when you're going to use the quadratic formula, we have to put this into standard form. So 1/2 x squared minus 5x plus 17 equals 0. And then let's pop it into the quadratic formula. So -b is +5 plus or minus square root of b squared. So -5 squared is 25 minus 4 times a half times c, 17, all over 2a, 2 times 1/2, which is just going to be 1, which is convenient, and we don't have to have a fraction anymore. All right, so we got 5 plus or minus, and then we're going to have 25 minus, so 4 times half is 2, 2 times 17 is 34. So 25 minus 34 is -9, so it's 5 plus or minus root -9. 5 plus or minus root -9 is going to be 3i. And there we go. That's it. All right. I think this is the last one. Yes, it is. Okay. So here again, solve the quadratic equation, support your answer graphically. Again, I'm not going to graph all these. You guys can type them in your calculator and see that they don't cross the x-axis. But this one's a pretty straightforward solution because the linear term, there's no x to the first, so we can just use square root properties for this one. If we divide by -2, and then we've got x squared equals -3/2, and we can just use our square root property for this to finish. And so we get x equals plus or minus. Now I've got, now that negative, you know, can come out as an I. I can put the negative with either the top or the bottom. Let's just say it's with the top. So I've got square root of -3 on top, and I've got square root of 2 on the bottom, right? And so plus or minus I square roots of 3 over, and I still have a square root of 2, which typically we don't leave that, so I'm going to go and rationalize the denominator like that. So plus or minus I square roots of 6 over 2 probably be the way you're going to see that answer. Now sometimes, well, yeah, they'd probably just leave it like this. Plus or minus I square roots of 6 over 2. I was going to point out on, that one didn't have a fraction. Oh, like say for instance this one. Sometimes some books, another way you might see the answers for these, they might separate the two different numerators. So you might say it's -3/2 plus or minus I square roots of 11 over 2. You might see it like that where it's kind of separated out, but hopefully you can connect it. That's the same thing as this. It's just, I usually leave them with a common denominator, but sometimes in the multiple choice they might break it up like this. All right, that's it. You can do the homework for 3.